Okay, we're in the SAGE projects document, PDF, and we're talking about the using SAGE, at least initially getting your feet wet with respect to the course that you're taking at Essex County College. It starts out at 119, it goes through 122. These are the foundational courses to moving forward to the STEM-related careers. So I think we're at this stage where I think we're at 122, and I think we just finished project letter D. I'm sorry, letter C. So I'm going to go to project D. All right. So the critical thing here is that you've certainly been working with Sage for a while now, including if you just start at the 122. That is, you know how to launch Sage, you know how to run a Jupyter notebook, and how to run a terminal. All right. So let's talk about the project here. And the project is a typical problem that you would give a Math 122 students. It's partial fractions with one of the integrations rather difficult to do. So we're given this integral over here. And what I did was again, you would have to go through the steps, of course. I go through the steps of breaking it apart into three separate integrations. And the first two are relatively simple to do. All right, these two over here. And then, sort of like this last one over here, I broke that one up as well. And I broke it up as, 2x over this plus 1 over this guy over here. This is the part where I want to point out that, I understand people get stuck, and I get stuck too. So I look at integration, I wonder if I can do it. That's what I often ask myself the question. I wonder if I can do that, right? And sometimes they're impossible. You get an integration you can't do, a machine can't do it. You kind of believe it can't be done. All right, but I got to be honest with you, this would be a little bit unfair for students, but I'd be happy to see you get there. Like if you had this problem over here on an exam and you're able to work to this level here, I would consider that a great success for you. I really would. All right, now if you had a lot of time on your hand, not an exam question, but a lot of time on your hand, my expectation is you could probably do that if you had more time on your hand. Exams can be tough though. So again, on exams, what are you doing? You're trying to struggle your way forward to getting the final answer. But the bottom line, you may not be able to get the final answer. You might get some partial credit for it, all right? Or possibly even full credit, depending what your work looked like, all right? Even if you didn't get to the end of it. So over here, what I did was I actually used a calculator to do the integration. I looked at it, and the calculator spit this back pretty quickly. And my response to that is if a machine can do it, it's worth a try, all right? So what I did was, if I were giving this to students, I would say hint, hint. I would give them a hint. This is substitution, by the way. And then, I continue to push them forward, about what they have to do to get to the end of it. And what's the end of it? This antiderivative over here. All right? So what I want to do is I want to cut to the chase, and I want to talk about, not me going through each step over here, the hand stuff. I want to talk about using SAGE. All right? Before I do that, though, I want to point out a lot of times what I do, I give students hints. Hints can be useful. They can also be highly distractive to people that see something different. There's nothing wrong with ignoring someone's hint, but the bottom line is pay some attention to a hint. Generally speaking, especially for the more experienced people, their hints might be helpful, all right? But what I want to do is just go to Sage. And again, we taught you how to launch Sage before. I'm just going to open my terminal up. Sage is already running. And I'm going to start typing the code in. So reset. X is a variable. And what I want to do is integrate. And what am I going to integrate? Well, I'm integrating the original problem. Let me go over that. And I'm looking at it over here. This is the original problem. And what is that? 4 minus x divided by x divided by the quantity x squared plus 2, that whole quantity squared, by the way. And I want to integrate with respect to x. All right? Now, granted, when I hit the enter button, Sage gets to work and actually puts an answer down there pretty quickly. I do want to warn you, though, the LOG in upper level mathematics, and including a computer algebra system, doesn't stand for log base 10. It's actually the natural log. All right? So when you see log in upper level courses, after you finish your studies at Essex County College, you move to a more advanced level mathematics courses, the LOG function is the natural log. That's base E, by the way, stuff that you studied back in Math 119. So that's not so bad. Certainly the calculator can do it, all right? And you might find it to be remarkable, all right? Now, whoops, I'm not going to get a project A. Whoops, sorry about that. I want to go back in the notes though, and I want to just type this one in over here. All right, integrate. By the way, if Sage can do an integral, that's indicating to me that I can do the integral too. All right, now granted, it might be tough for me, because I don't sit around doing integrations all day long. But the bottom line, integrations are sort of like solving a puzzle. We have some techniques for solving puzzles. Like if you're doing a jigsaw puzzle, start at the edges. Right? If you're doing an integration, you start with known techniques like recognizing, use substitution, integration by parts, substitutions, yada, yada, yada. Partial fractions, things like that. All right, so let's see if we can do this and see what Sage is going to say. And you notice how quick it does it. It's remarkable how quick it is. I really mean that. It's remarkable. Here's another problem students often have. Oh, by the way, there's no constant integration. It's assumed that you understand that, by the way. The deal about this one over here, you may look at this, which is the answer, and see it being different than the answer over here. It's identical to the answer over here, all right? Again, they might write them, it looks a little bit different. They might, do some simplifications over here. But I do see, square root of 2 divided by 8 times the arctangent of, let's see, the square root of, well, they write this a little bit differently. And the reason, I guess what they're doing is rationalizing the denominator. I don't see them mind it, but it's really the same thing. And then plus, by the way, they do factor out a 4 on that one over there. So that'll be 4x squared plus 8. I do see that. Yeah, it looks beautiful. The only thing you're really missing is a constant c. All right? So what's this about? A lot of times you're going to be given an integration. You know where to start, right? On this one over here, I would definitely say partial fractions would be the way to go. And then kind of break it up into separate problems. And the separate problems should be much simpler to do. For example, breaking into partial fractions, I get 1, 2, 3 partial fractions. This is simple. The second one is simple. And breaking this into 2 parts also is quite simple to do. And you can do the integration there. It's really kind of simple to do. All right? Here's the deal, though. When I say you can do the integration there, for the most part, you can do the integration. Where you're going to get trouble is this over here. All right? This is where I often give students hints. I want to point out hints can be useful if you can understand what the hint is. Right? If you can understand the hint. Again, a lot of times the hint is almost like speaking someone to a foreign language. They don't know what the hint is giving them. It's generally giving you a method to get to the end of the problem. All right? So I'm going to say that's about it. There's not much code over there, but it's about it for that particular section. But again, what your goal is to study what we're providing for you. All right? Thank you so much for paying attention.